Alright, I'm back. And this is where we left off last time. We got the game so where we can click and the computer makes a random move. Sometimes the move doesn't show up. And the reason for that is that we don't have... Right here we added X to the grid. So if we copy that, we can add Y to the grid. Right here. So that the computer doesn't make the same move more than once. So we'll just add these in as variables so that we can reuse them. By the way, I'm just continuing off from the last tutorial. If you were not sure what this is about, you should watch the first one. It's going to be linked in the video later. Y equals... Alright, now the computer shouldn't make the same move twice. Double check my code here. It should run. So every time I move, the computer should make a move. Yep, so far so good. Until there's no moves left. Yep. Perfect. Right until no moves left. Okay, so from this point, we've got it going till there's no moves left, and there's square taken. Basically, we can't click on the same square twice. So the only other moves we have are to solve for a win. Now, this is going to get a little bit more complicated. And this will check to see if you actually won during your move or the computer won. So what we need to do is make another function. We'll just call it check. And we'll set it up so that the variable win is 0. That means nobody won. That way it's set up to be clear. And then we make a loop, because we need to scan the grid. So we need to check across and down and the two diagonals for a win. So we can do that in one loop. For y equals 0. Start at 0. Y is less than 3. Between 0 and 2. Y plus plus. So yeah, we're only using a 3x3 grid. That's all we need to scan. Now this is probably going to get a bit complicated, but let's see if we can get you to follow along here. Not phi, if. Doing Python now. Python? I don't remember. Okay, if grid Y oh wait, we're putting X first, weren't we? Okay. Okay, if grid 0 and Y, basically this row here, every time Y increases, it's going to go up here and here. This scans the first row. If grid 0 and Y and grid 1 and Y and grid 2 and Y. Actually, no. What I said earlier was wrong. We got 0 and Y. Y starts off at 0. Then we're going to go over 1. We're scanning the top row here. So 0, 0, 0, 1, and 0, 2. If I click this, you should see 0, 2 over there in the corner. 2, 0. You're going over 2 and down 0. Yeah. I think I said that backwards earlier. So yeah. X is across. You got 1, 2, and you're going down 0, so you're staying on this one. This be 1, 0, 1, 2, and 0, 1. So this be 2, 1. Those are the numbers we're working with? Okay. So if 0 and Y equals oh no. We close that up. Oh, there's an extra bracket there, that's why. Alright, so this bracket, round bracket matches up with this round one because it's gets a square on it. Okay. So that basically checks if there's something in each grid section. So if there's something in each grid section, then we have to compare that they are all equal. So equals So if this equals, the first one equals the second one, and second one equals the third one, then basically that means alright, so basically what that sums up, that line, 83, means is if this one equals this one, and this one equals this one, then that's 3 of the same characters in a row. And therefore it triggers a win. Now to scan downwards. We'll push this down. Put the same function here. To scan downwards, we just gotta reverse. We'll still use y because y is the only variable that changes in our for loop here. Oops, an actual 0. Y, 1, 1. Y equals 2. Y, 1. Y, 2. Okay. So this basically just reverses the 2 coordinates, so it scans downwards. If I programmed it right, it first checks that all 3 of these are full. If they're full, then it checks if these 2 match, and if it checks if these 2 match. If they all match, then it's a win for whoever played. Because of the way tic-tac-toe works, it's turn-based. If you call that check function, after every player, basically whoever placed the last move, if there's a win triggered, it'd be the person that moved that won. That's how that works. So that just checks the up, down, left, and right. Horizontally and vertically. Another way of putting it. Now there's an X here. That's because I'm missing a bracket. That black bracket belongs there, and that one belongs there. So there should be one here. Right, so on... And then at the end of the function, we're only checking for a win, so if we hit return at the end of the function, it returns the variable win. Basically, it starts off at 0. If any of these conditions are true, win becomes 1. That lets you know if someone won. I don't have it scanning for the diagonals yet. I have to put that in after. But we can test that once I find the click. What did I call that? Oh, mouse click. Mouse click, we're gonna put, this is where it gets added to the grid. This is the check function I made earlier. This is check. Checks for the win. So when we place this on the grid here, we'll call a check function, and we'll copy that. And when the computer places their move on the grid, which should be an O actually, and not an X, we can run check here too. Actually, we should go a bit further beyond that. If check. Basically, an if statement evaluates true or false. So, yeah, let's go down here. You done if 1 equals 1. 1 does equal 1, so that's true. And whatever you put in these brackets gets executed. However, if you put, actually it should be double equals. That's the other thing that might trip some people up. If you're comparing something, it's a double equals. If 1 is equivalent to 1. However, if you're assigning a variable, it's just 1 equals. So yeah, you use the double equals there. If it evaluates to false, 1 equals 0, then it'll run this code that would be right here. But 1 will never equal 0, so it'll never run that code. That's another way to disable something. So if we get rid of that, basically what this is saying is if we have check set up to return either a 0 or a 1. So if it returns a 0, that means nobody won. And a 0 would be false, so it wouldn't execute this. But if it returns a 1, that someone won, then this function would consider true, and then it would execute whatever's in here. So if it was true, we could use this debug statement again. And we're under the letter O. So we do the same thing up here with the other check. We'll paste that here. So if check comes back positive, we'll say X wins. Well, that was a lucky random move. You gotta be kidding me. It said O wins. So that function does work. We could run again and see if I can pull off. See. Okay, the reason it says X wins and O wins is because we don't stop the execution. Whereas it says X wins here. And then it just continues on with the rest of this code. We need a way to skip. We need a way to skip. I'll turn skip off up here, but when it gets down here, if X wins, then it should skip over the computer stuff right here. And we don't really need to calculate if moves are left. Alright, we can ignore all that. If skip equals 1, now we're going to re-indent all these just so it looks pretty. Okay, so if skip equals 1, it'll skip over all that. It won't calculate a computer move. So if I do manage to score... Why didn't it move at all? That shouldn't have made a difference, but... yeah. What did I miss? It didn't say X1. All I did was add this in here. Yeah, JavaScript can be weird sometimes. Or difficult to decipher. Oh, or if you code it wrong. If skip doesn't equal 1, do that. Okay. Basically, this is saying if skip equals 1, if it's... We have skip set up here. If you win, I set it up so that if skip equals 1, it'll execute that. But what we want is if skip doesn't equal 1. And that should be it. There we go. And now it says X wins and... oh, we didn't play. But we can still keep clicking because the game doesn't end. We'll set that up later, but the CPU stops playing. Now, where did we leave off? Oh yeah, we needed to set up the diagonals here. That's where we should finish off first so we can finish this function. So to check for the diagonals, we can copy this here to save me some typing. And the diagonals work. This is 0, 0. This is 1, 1, and this is 2, 2. So basically all we do is just fill the numbers in. 0, 0, 1, 1, 2, 2. So if anything exists in all three of those, we'll check to see if they're equal. 0, 0 equals 1, 1. And 1, 1 equals 2, 2. Then win equals 1. And we'll copy and paste that. And the other diagonal is 2, 0, 1, 1, and 0, 2. So we fill those in. 0, 2, 1, 1, 2, 0. Doesn't matter what order they're in. Just as long as the coordinates are there. And we can do the same here. And so it needs to be 2, 0 on this side. And that should calculate the diagonals. So if I was able to pull off a diagonal here. Oh, sometimes the random computer is just really good. It should say that I won. Alright. Let's try the other diagonal. And it says that I won. Perfect. And we confirm that going across works. And we confirm that going downward works. And downward works. Alright. So, the next step. Again, if you didn't catch all that, you can easily rewind it. If I'm talking too fast, you can set the video speed too. Like half speed or something, so I talk a bit slower. But that gives the check. And the other thing that we were doing is that if there was a win, we could keep clicking. We should fix that right now since I remember doing that. That's usually done with a global variable, so we'll add it to here. We'll just call it done. We just add it to the end of the variables that are already defined up here. Actually, we'll set it to 0. That way there's no confusion. So now we go back down. There's no moves left. Done should equal 1. If somebody wins, done should equal 1. And if I win, done should equal 1. And just doing that alone doesn't do anything. You gotta go right up to here. If done equals 1, wrap that in some parentheses. Put the curly brackets. And put a return there. Basically, that means if done equals 1, return just kicks us back out of the function. Nothing else gets touched. So if we run that, if the game ends, there's no more clicking going on. I can't click anywhere else. And if the computer manages to win, we can't play anywhere else. It just says O wins. And if there's a stalemate, well, it won't let us do anything anyway. Because that was one of the first things that we set up. So that pretty much covers how to make a random tic-tac-toe game, which isn't very challenging because you just draw a line and you win. What if we want to go above and beyond that? And actually make the computer a wee bit smarter. It's not exactly AI, it's just a little bit more logic. Let's make a function called scan. And let's see if we can make computers just a little bit more smarter. So, in order to do that, we need to execute a certain number of loops. Because we're gonna base it off the last move. So say if I moved here, I need to check here, here, and the two diagonals. Whereas if I landed here, I only need to check here and here. So we'll base it off a certain number of loops. We'll call it player. Okay, so we'll take the... We haven't been using this at all. If you put variables in here, they become available down here. So we can execute the function scan, and we can put X and Y in there, and then it's available in the function. We'll make player. Oh, I missed the equal sign. We'll make player be grid X, Y. So when we run the scan, whatever character, letter, Z, X, Y is what we're going to be checking against. It generally should only be done against X, considering the person clicking is X, but could just as easily put X there if I wanted to. But we're going to do it this way. Either way, it needs to know what character to check against. So, first things first, if X equals 1 and Y equals 1, loops equals 4. So like I was saying, this is 1, 1. This is 0, 0. This is 1, 1, and 2, 2. So if it's 1, 1, we need to scan 1, 2, 3, and 4 times. That's why loops equals 4. Now, if we'll just copy this so I don't have to type it all out again. If X equals 1, Y doesn't equal 1. So if X equals 1, this is X equals 1, and Y doesn't equal 1, it's basically this square or this square. We only need to scan left, right, up, and down. So we only need 2 loops. And again, this could be simplified, but just to keep it understandable at this point, since this is for beginners, I'll keep it simple this way. And we'll do the same thing for the other side. Basically, if so basically those two statements I just put in are for checking for these squares. These squares only require 2 loops. These 2. If I go here, it's these 2. Go here, it's these 2. And here, likewise, it'd be these 2. Oops. One more. There we go. And if loops hasn't been defined, if not loops, another shortcut, you could go loops equals 0 as well. There we go. It starts off as 0. If it isn't set here, then it is still 0. Then we'll make it 4. So that would be the corner squares. 1, 2, 3, and 4. You need to scan these vertically, horizontally, and diagonals. Technically, it's only 3, but then we'd have to figure out what diagonal it needed. So this one's different than this one. So we'll just call it 4, so to scan both the diagonals. I don't think it makes much difference. Not my test anyway, earlier. Alright, so that sets up the number of loops we need to do. So now we need to make the loop for I. If you're in strict mode, you have to type var in front of your variables to define it as a variable or a constant. If you're not in strict mode, it doesn't really matter if you do, but it's a good practice to get into. Basically, only when you first define it, like at the top here, as a global. Global means it can be used within a function, the same variable. Like debug, for example, is a global, so it can be used in the function and it can be used in anywhere else in the page. But if it wasn't set as a global, like if you defined it here inside the function, like this one here, var I, it only gets used in this function and it doesn't get recycled anywhere else. But yeah, you only have to use it when it first gets defined. Like loops is only used in this function. That's where the var comes in. If you're using it anywhere else, like grid here, it doesn't need a var in front of it because it's already been defined up here, var grid. That's how that works. Var I equals 0. I is less than 3, which basically means from 0 to 2. Because it's 2 is less than 3. And I plus plus. We're going to increment I. And here's our loop. Oh, actually, we're not doing it at 3. We're doing it at loops. Loops. That's the whole point in setting up loops earlier. So it's going to loop however many times this is. If we need 4 loops, it's going to be going from 0 to one less than whatever 4 is, which would give us 3 loops, because we're starting at 0. Enough of that. That's just basic JavaScript. So in the loop, we're going to define a couple more variables. We're going to define an X and an R array. So an array is a variable is basically a single amount of data, whether it's a number or a string, letters, numbers, whatever. An array is several strings or numbers all combined into one group. So to scan horizontally, it'd be similar to this up here. We're going to have to go across X 0, 1, and 2. Just a different way of doing it. Actually, since we're going to be using these several times down below, we'll just define them up here. Why? So yeah, similar to up here where we are scanning the grid, to scan horizontally. Was this one horizontally? Yes. So we're scanning at Y. Okay, so X is this way and Y is this way. So we're scanning at Y, is down. So whatever position Y we're at, we're going to scan. It was position 2 Y, 0, 1, and 2. And that's what that is. That's just for scanning the rows. Oh, actually, this belongs down here in the for loop. My bad. And we should define them as arrays, actually. Yeah, these don't get used past this loop, so they can just get defined here. And we'll put them on the same line. Okay, so if this is how our loop is set up, I equals 0, so for the first loop, we want to scan, what would we say that was? Vertically? No, that's horizontally. Y is fixed. Scanning Y at 1, 2, 3. Okay. And we need to, and then the second loop, when I again increases to the next one up from 0, which is 1, which will be the second loop, we need to scan downward. So the first one's click. First one scans across at whatever Y is. Next one scans down. And then we do the diagonals. So at loops 3 and 4. Each inversely are 2 and 3 because you're starting at 0. That could get confusing after a time. This one's easy. And 1, 0. And this one's the inverse. Okay. This has mostly been explained up before. It's basically just the grid numbers. We're going to set up a counter here. And this is where we run the loop where we actually scan. We'll call this II because we're still in the first loop. First loop ends down here somewhere. I probably don't have enough brackets in yet. Or wrong brackets. They're all supposed to be the curly one. There we go. Okay, yeah. So this is still inside, as you can tell by the boxes. This is still inside the main 4. For II equals 0. And this is where we're assigning the variable. This is where we're comparing the variable. So if we were going to do something that was equals here, we'd use a double. But anyway, it's less than 3. We're actually scanning the grid this time and not checking loops. And oh, it's not V, it's I. By I is less than 3 and II plus plus. So this goes from 0 to 2. And there's not much to show here yet because it's just a bunch of numbers. We'll actually have to do something first. Now we're going to want to count. Okay. This is a ternary I'm going to do next. Another new thing to learn. We set count 0 up here at the beginning. Okay, so every time it checks what array you need, these, every time this loop goes through, it sets count 0 before it runs this. So count equals period there are the coordinates. And then we check this against layer that we defined earlier all the way up there somewhere. Layer. Basically, we're searching for all the X's. So in order to find the X's, we're going to check the points that are mentioned in these arrays. So XX equals, the one equals ARX II. Okay, what this means is it sets XX, the variable XX, as whatever's in ARX. ARX are these up here, 0, 1, and 3. So on the first loop it's 0, it'll take the first one. Next loop it takes that one, and next loop it takes that one. So all 3 times it cycles through here, it'll grab one of each number. And if I copy and paste that, call it YY, and then we take from array Y, basically it's just grabbing one of each of these numbers. And we plug these into the grid. Okay, so as a ternary, this is how this works. We're assigning a variable count. A value depending on what this is. So we'll put the question mark here. So the best way to explain this, if what are all these extra brackets doing here? Excuse me. They're not supposed to be there. Whatever is at grid X and YY, depending on what group it took it from. If it matches an X, we want to add 1 to the value of count. So basically, if it goes through count 0, it's going to add 1, it'll go up by 1. If it's already 1, it'll add another 1, and it'll be 2. It just increases the value. And the second value after the colon, if this evaluates true, then it executes this one. If this is false, it evaluates this one. So count just stays the same. Count equals count is how you read it. Count equals count. The number doesn't change. But if it's true, it just evaluates this, and the count equals +1. Count +1. It's just a conditional adding to let you know how many are in the rows are in there. So right now, I'm going to use that echo function. And it is a function because it's one that came with the colinglover.com/dev. And echo is right here. And debug is right here. I'm going to use the echo function. And we're going to output count. We'll do it after the loop so that we don't get a whole bunch of printing. So it's going to run the loop, and then it's going to put count over in the debug log over here. So in order to get to run the function first, we need to have it scan What we want to do is for the CPU section right here, we want it to scan XXYY. First, we have to find out okay. XX and YY are the actual. This is where we do the math to determine where we clicked. It's XXYY. So we change that to XXYY. And it should scan that point that we clicked on. If I hit run, might be hard to see, but when it scanned across, it found 1. And scanned I don't understand that output either. Gonna need more information. Okay, so when this echoes, it should echo the X and Y location and then the count. Actually, we can do even better than that. We can put some strings in between it, separate it all out. All right, so the first scan it came 1. Second scan it got a 1. And this diagonal here it got a 1. The other diagonal didn't get anything. There was 1x. If I put 2 here, oh yeah, these XYs mean nothing, don't they? Do. Okay, I know what I need here. Actually, yeah, maybe that needs to be up here. So we can actually see what it's doing, because X and Y changes throughout the loop. We should have cleared that. Made it easier to see. Okay, so 0, 0. There isn't anything. 1, 0. There's an X. And 2, 0. It only found the 1x. Then it goes goes, wait, no. Why is it 0? Okay, yeah, it's scanning. Zero, 1. Okay, and then 1, 1. And then 2, 1. So it's scanning down here, although it should have found something at. Actually, that kind of looks. Yeah, it should have got an X at both, but I think it's scanning the wrong one. Yeah, why is it there? Did I put the right numbers in? Oh, no, I didn't. My bad. That's why it's confused. X and Y need to be different. I should have cleared it. Okay. So 0, 0 is, there's nothing here. It didn't count anything. 0, 1 is 1. It found something. And 2, 0 is also 1 because it counted just the 1 as it went through. Next is 1, 0 here. That counts a 1, and there's only that 1 that it counts. So I put another 1 in here. You're getting 0, 2, 1, 1, and it still only found the 1 up above it. 0, 0, 0 for the diagonal. Anywho, it is counting. By rights, I need a split in there. So we can easily divide them up. So I'll throw a split in there now. We'll just call it break. So that way we can tell all these numbers apart later. Alright, so if I went here. So these are the groups. So it's scanning across first, 0, 0, 1, 0, 2, 0. And then it scans down, 2, 0, 2, 1, 2, 2. And both times it only finds 1x, because there's only 1 there. And it also finds 1 on the diagonal. clear that again. I put a second X there. Then it will, this is the second one I put in. Zero, 1, 1, 1, then it finds its first X right here. Then it scans downward, I'm guessing. 2, 0, finds an X. 2, 1, finds its second X. And there's nothing at 2, 2. So it stays at 2. So yeah, it is working. Basically what we want is if it finds 2 X's, we want the computer to block whatever the empty one is. We have to figure out what the empty one is. So grid XXYY. So empty will be whatever one is at grid. Gonna check the variable grid XXYY, and this negates it. So if XXYY equals nothing, then we're gonna set empty as XX plus YY. Otherwise, empty is going to stay empty. The reason that there's a string in the middle, or an empty string, is because if I just do XX plus YY, it'll add them together. So we put a string in between, so it makes it literally whatever these two numbers are, 0 and 2, or 2 and 0. That's how we got it set up to run up there. So now we have a count value and we have an empty value after every loop. We don't need this echo anymore. We can comment that out. And we don't need that one. We can comment that out. So at the end of that loop, we do if count, actually spell count, greater than 1, which means if it's 2, actually we could just make that equals 2. Then what we want is to return empty. So empty would be whatever numbers came up through the loop there. Returns the empty position. If there's, go back to my iframe, if there's two things there, like this one here, it'll return the empty position, which would have been 2, 2. And then when the computer plays, it'll play the 2, 2 once we set that up. Scroll, scroll, scroll. So scan XY. We'll make that play. Play comes back. There's no play value. Then we'll do the random thing, which is this one. Yeah, it's this one. Otherwise, we want to yeah, we'll just do it this way. Play dot char at 0. YY equals play dot char at 1. And if I do that right, then it shouldn't play randomly. It should actually block my moves. But occasionally this thing likes putting extra parentheses. God. Parentheses. Oh, okay, I give up. Putting extra stuff in there. Oh. Tried to do something. Cannot set property undefined of undefined at MC. What line is that at? Is that 93? Down to 3 if click. Oh, if check. Wait, no, that's 93. Oh, 92. I'll just put a return there. Turn false even. I don't think that was it, but we're gonna try it. No, it's still the same error. Cannot set property undefined of undefined. That makes no sense. Pretty sure it was in that code we just put together. So the easiest way to debug that is to get rid of the code we just put in. Yeah, something to do with the code we just put in. Because now it plays fine. Yeah. So something in that new code, scan, needs to be looked over. Now there's a... some reason has a problem with that, but it checks out. What is the issue of undefined? Here, let's turn this echo back on. So it got through to the first two. Okay, so cannot set property empty. I'm guessing it has to do with what returns. I'm returning empty. Let's echo out empty and see what it says. Empty equals 22. Yep. 2, 2. It's doing what it should be doing. What did I miss up here? Play that chart 0, play that chart 1. Now I am confused. But I can throw another echo in here. Hide these echoes. This is where the debugging comes in. Yeah, something's getting thrown up here as undefined. Yeah, it worked when I done it on the script I have here, but I changed a couple things as I went through. So it's not exactly how my script went. So now I just have to find the error, that's all. Give me a minute. Let's try it a different way. Comma. Nope, plus. We're just gonna turn it into a turn. That's what we're using here is turn. Basically, if it comes back from play with an actual value, then it'll put the two. Actually, I don't even need to do that, I don't think. Turn equals play. It should just work as normal. Oh, it's not doing anything. Now it's not doing anything. CPU equals 0 because there's only going to be one move. Otherwise, it'll execute the random stuff. Does that work the way I intend it? No. I think it did. It just came up backwards. Let me... reverse these for some reason because they are 1 and 0 here. Chara is not a function. Okay, well, everything was going swimmingly until this decided to... not cooperate. It's a shame. One comma 2. That's what I see here. But it's putting it in backwards. That looks like it's coming out as 2 comma 1. That's what I'm seeing. Alright. Try this one more time. Plus play dot char at 0. Is that the issue, the string thing? There we go, it blocked me. Wonder if that was just random. Nope, it blocked me the second time. And the third time. But I still won. I think I got it. Yep, it's blocking me. I had two choices there, so but it already won. Wow, I didn't even see that. There we go. Now there's a wee bit of figuring stuff out. Okay. So for some reason it just crashed there when I clicked that button. Yeah, the first one. Why is that? Something is empty. Guess I should fix that really quickly. Play doesn't equal false. That help with that? Oh, it still crashes there. Just that first square, right? Yeah. Oh nope, it's this whole line here. But it's only on the first try. Alright, let's solve that too while we're at it. Reference area empty is not defined at scan. Maybe that's the problem. And we also don't have a var empty, do we? There we go. I'll run it. There's no error there. There. Yeah, it's just because we didn't have it declared. Alright, so then after we do all that, we give a quickie run through and see if we can find all those echoes. Although most people don't check the console anyway to the debug console to see this stuff, so I mean technically you could leave it there, but there's no reason to do so when we can just echo it all out. Okay, there's still a false and a 1 coming up. Where else do I have an echo thrown in here? Right here. Do I have any more? The debugs are fine because I'm using those to show the win message. And run. Clear. Oh, it doesn't look like it. Hey, it didn't block me. But it blocked me there. And there. Oh, it blocked me that time. Oh. That's not gonna work. Yeah, it seems to block every other way. Except for here. Apparently there's still bugs coming up. Although it did in the second time. So I also just noticed something else. The square is taken, it doesn't run a skip. Okay, so now if the square is taken, it doesn't play a move. Blocked me there. It blocked me there that time. And it won that time. Doesn't seem to find this one. Tricky. So we'll put this echo back. How long's this been now? Probably too long. We'll put the break back. Right, so it checked 00, 10, and then it found something there. Although that's a bad run because I need that corner empty. Need that empty. There we go. Perfect. 001, 111 because it only found that one. That diagonal's 0. That diagonal's 1. Okay, so if I click the next one. It does 001. 02. 11. Oh, 02. 11. 0. That was the diagonal. So it only must be 4. Oh, okay, it's this one here. 00. 10. 20. Should have detected that one. What did I miss? Bar empty. Grid XY equals But we try that. Nope. Nope. See, the text of 2, but it doesn't come up with the empty. Oh, wait. Do I not have... Oh, I don't have the echo empty on. Okay, it echoes empty 0, 0. Okay, so my function works. Then if my function works... then it's that false thing that's having an issue. Because 0, 0 is technically false. I think that's why. So we make it -1. It'll complain about it horribly. Oh, play doesn't equal -1. Ja. Now it's blocking it. Blocking me there, blocking me there. But there were 2 choices, so it failed. Blocking me there. Blocking me there. Oh, tried to go where it already went. And it could only block me one place there. So there you go. That's how you make a tic-tac-toe game. It's slightly smarter than... Why did it go to 1, 0? That doesn't make sense. Oh, because it probably... And that's something else we should test. There's still some bugs here. Anyway, I'm gonna call this because this is probably way longer than I wanted it to be. I'll probably do a video 3, which will go over these bugs and finish it up, but it pretty much does what it should do, and is that you play a tic-tac-toe game. Now, occasionally there are a couple bugs that creep up for some reason, but for the most part, it's there, and that was the goal. The occasional bug here and there, that's something I can look at later. So I'm going to call it a night. Catch you later.